Good morning, Pre Calc. Today we're going to do extra examples from chapter 12.3. We're going to name it today, name the formula today, and I'm going to do one polynomial, one square root example, and then one rational expression where it has a fraction. These would be the three different types of problems. And I'm going to kind of ask the question in a couple different ways so you can see how the question would be answered depending on how they ask the question, and we'll go from there. So the formula we've been dealing with is called the derivative. It actually has a name. It's such a important formula in upper level math, in calculus, that they named it. And it's called the derivative because you derive it from the original equation. You take the original equation, you apply this formula that we've been looking at, and you come up with equation for the derivative. And what the derivative is, it has a lot of names. It's called dy dx, or change in y over change in x. There's one called y prime, d f of x over dx. These are all notational ways of stating the derivative. Also called instantaneous rate of change at any point. If you go anywhere along a curve, you could find out how fast you're changing at that specific point. Even though the rate isn't constant across the curve, you could find out how fast it's changing at that specific point. So we call it an instantaneous rate of change for the function. And it's a really powerful formula. So we're going to get into it right away here. We're going to find the limit as h goes to 0 of f of x plus h minus f of x over h. And the presiding characteristic here, the reason we're going to have to do all this algebra, is because I want to use direct substitution. If I plug 0 directly in, I get f of x plus 0. So I get f of x minus f of x, which is 0. I plug 0 in on the bottom, I get 0. I get this form called 0 over 0. It's called the indeterminate form. And whenever the indeterminate form comes up, there's some algebraic things that you can do to the function, due to the formula, and it's very, very similar for every single problem. I mean, if you get a problem that looks like this, you're going to basically be doing the same type of algebra every time. But there's a prescribed set of stuff that you can do to it, basically get it to the point where you can whap a whole bunch of stuff out, and what's left over will be the value that you'll be able to plug the h in and then actually find the derivative. So let's get into it here on this problem. Find the derivative of this. So I'm going to do the limit as h goes to 0 of f of x plus h. And f of x plus h tells me to plug the x plus h in for the x's, for both x's. So I'm going to go 3x plus h squared minus 2x plus h. And this part right here is the f of x plus h. I was going to write it, maybe I can hear. The limit as h goes to 0 of f of x plus h. That x plus h, that's the red part. And then what I'm going to do, the next part, is I'm going to subtract the f of x. And f of x is just the function itself. So if I'm going to subtract the function itself, I'm going to go minus the function, which is minus 3x squared minus 2x. That green part is that green part. And then the formula says divide by h. So I'm going to put divided by h. And those are the three real parts of the formula. Those are the how you want to break it up, how you want to think about it. You got the first part, the red part minus the green part, all over the h. And now it's a process of, can you do the algebra? Can you do the algebra 1, algebra 2 stuff that is going to require to do the problem? So here we go. The limit as h goes to 0 of, this I'm going to have to FOIL, and I'm going to take a couple shortcuts to foiling. If you don't agree with what I FOILed, go ahead and go off to the side, take x plus h times x plus h, first outside, inside, last, and see what you get. But what you're going to get is you're going to get 3x squared plus 2xh plus h squared. And that's fairly simple math, foiling that out. I'm going to go ahead and distribute minus 2x minus 2h. I'm going to distribute again minus 3x squared plus 2x all over h. And I'm going to continue to simplify. The limit as h goes to 0 of 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h. And at this point, our hope is that we're going to get some things to cancel out. So let's see here. My 3x squareds go away. My 2x's go away. And that's it. So I'm here at this step here. Okay? Oop, let me erase that. It's just an algebra problem now. We're just basically going through and trying to cancel out. So I'm going to take the limit as h goes to 0 of 6xh plus 3h squared minus 2h all over h. And at some point on the top, you're going to be able to take either factor something out or cancel something out on the top with something out on the bottom. And I do notice they all have h's here. So I'm going to pull that h out. I got the limit as h goes to 0 of h out in front. I'm left with 6x plus 3h minus 2. I took an h out of that, I'm left with 6x. I took an h out of that, I'm left with 3h. I took an h out of that, I'm left with minus 2 all over h. At this point, the h's cancel out, and I'm left with the limit as h goes to 0 of 6x plus 3h minus 2. And I got it down to basically what is a polynomial. And with any polynomial, we can use direct substitution. So I can take the 0 and I can plug it in, and I get 6x minus 2. Now what that is, that's an equation that will give you the slope. The slope is also called the instantaneous rate of change, also called the derivative, also called dy dx. I have all these funky names for it because it's so important. It'll give the slope of the tangent line of this graph at any point on the graph. So I'm going to put m of tangent. Put m of tangent. And I'm gonna graph this guy on here. So I'm gonna graph my original, which was 3x squared minus 2x, I think. Let me go back up and make sure I got the right one. 3x squared, yep, 3x squared minus 2x. And I'm gonna graph it. And I got a parabola, which I would expect. It's like down in here. It's like right there. It kind of dips down. I'm not even going to get it exact. I'm going to go like that, something like that. So I have this parabola, and at any point that I would choose along this parabola, if I chose a point, chose a point, chose a point, I could find out how fast that graph was changing at that point with this formula. So let's look back up into on the problem. It says, find the slope of the tangent line at the point 1, 1. Oh, so it goes through 1, 1. I'm going to trace 1 on my graphing calculator. What do you know? On the bottom, when I traced 1, I got 1. 1, 1 is on the graph. So my graph's even a little bit off. I should probably go fix that. Let's go fix that. 1, 1. I want 1, 1 to be on my graph. So here we go. I know it goes through 1, 1. It dips down a little bit here. It's a little sharper than I thought it was, something like that. And probably comes back something like that. So here's the point 1, 1. And the question is, what is the slope at that point? Well, to find the slope, you take the x value and you plug it into the slope of the tangent line equation for the x. So the slope is equal to 6 times that 1 plugged in minus 2, which is 4. The slope at this point is up 4 over 1. 1, 2, 3, 4 over 1. Hey, that, I'm going to dot it in. That's a pretty good slope. The last thing that this problem asks for, this problem says, find the equation of the tangent line at the point 1, 1. So not only are we going to be able to find out the instantaneous rate of change, but we're going to be able to find out the equation of the tangent through that point. So I'm going to use point slope formula, y minus y1 equals mx minus x1. I know the slope is 4, and I know the point is 1, 1. So I'm going to go x minus 1 and y minus 1. I got my 1, 1, and I got my 4. 1, 1, and 4. And I can write the equation of this tangent line pretty easy. 4x minus 4, y equals, well, if I add 1 over to the other side, I get 4x minus 3. And look at that. It crosses right down there at -3, up 1, 2, 3, 4 over 1. Looks like I got it. So there's my 3 parts. Here's the slope of the tangent line, my m. Here's the equation of the tangent line. And here is the derivative or an equation for the slope of the tangent line at any point. Okay? That was example 1. That was for a polynomial. Polynomial 3x squared minus 2x. Very prescribed set of algebra, very prescribed set of things. Okay, next one. It says find the derivative of f of x at root x minus 2. And I know what root looks like. It looks like a hill, and that minus 2 is going to bump it over to the right 2. So I'm going to start by graphing this. So it's going to go something like that. Okay, so I know what the graph looks like. And it wants us to find the derivative of this. Well, we apply the same formula. It's just the algebra. The algebra gets a little bit different here. So let's try this. We're going to find the limit as h goes to 0 of f of x plus h. F of x plus h. So I'm going to take the x plus h. I'm going to plug it in. So it's root x plus h minus 2. This x plus h went in right in for that x, minus my function f of x, which is root x minus 2, all over the h value. So I get there. And I'm going to, just for emphasis, red, this is the red part. Green, this is the green part. And black, here is the black part. And those are the 3 parts of the formula. Okay? X plus h plugged in for the x plus h plugged in for the x, minus the function, all divided by the h. Those are the parts, that's the setup. And now we have some algebra. And again, if I try direct substitution, watch. I plug in a 0, I get root x minus 2 minus root x minus 2. That's 0. I plug in a 0, I get 0 over 0. I get the indeterminate form. I can't do it unless I do some algebra simplification. So direct substitution doesn't always work. Didn't work here. We got to do something else. So what I'm going to do here is the process described in the last section. I'm going to rationalize the numerator. So I'm going to pick a clever one. I'm going to pick a multiplier that is going to take this radical stuff and kind of basically transform the top into a different looking thing. And that conjugate is what I'm going to use. So I'm going to take the same 2 terms, x plus h minus 2 and root x minus 2. And I'm going to multiply by it, and I'm going to put a plus sign in between the 2 because those 2 are conjugates. And I'm going to multiply by that on the bottom too. X plus h minus 2 plus root x minus 2. And that's really the algebraic technique when you have radicals. When you're going to do the derivative when it has a radical in it, the algebraic technique is you're going to multiply by the conjugate on the top and on the bottom. And you pick this top one, and you write down the same 2 terms, and you switch the signs. Okay? On top, we FOIL the limit as h goes to 0, h goes to 0 of. So I'm going to multiply these 2 times each other. Let's get rid of that. Those 2 times each other, they're the same 2 terms, so the radical goes away. So it turns into x plus h minus 2. These 2 terms and these 2 terms, when you multiply by conjugates, you get first, outside, inside, last. Those 2 terms in the middle, they combine together and they drop out. That is the idea of a conjugate. So these 2 terms and these 2 terms wipe each other out. Bam, 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 bam. And then my last term is minus, because there's a minus and a plus, and it's minus root x minus 2 times root x minus 2 is x minus 2. Don't forget the parentheses. Probably the most commonly missed thing right there is just dropping those parentheses because it's minus the whole thing. All over, and the bottom we're just going to leave. Root x plus h minus 2 plus root x minus 2. And this is kind of like a factored form here on the bottom. We want to be able to leave that so we can wipe things out if we need to. So here we go. Let's do some algebra. Limit as h goes to 0 of, well, x plus h minus 2 minus x plus 2 all over h times root x plus h minus 2 plus root x minus 2. All right, so I distributed the negative. That's really all I did there. Let's look for things to cancel out. The x's are gone, the negative 2's are gone. All right, let's see what's left over. Let's keep going. We'll find the limit as h goes to 0 of, well, all I have left on the top is the h. On the bottom I have h root x plus h minus 2 plus root x minus 2. And I hope you can see right there, I hope you can see why we didn't go ahead and distribute it through. We wanted to leave that h there so that we could wipe those two out. There is a 1 left over on top, don't forget about it. The limit as h goes to 0 of, h's wipe out, I have 1 over root x plus h minus 2 plus root x minus 2. And at this point what I can do, I'm going to go over here, at this point what I can do is I can take the 0 and I can use direct substitution, and I can take the 0 and I can plug it in for the h. When I do that, I get 1 over root x plus 0 minus 2, so root x minus 2 plus root x minus 2, which is 2 root x minus 2's. So when I actually, I'm going to show that step. I'm going to show that direct substitution step. Root x plus 0 minus 2 plus root x minus 2. And you notice that 0 doesn't even really need to be there because, it's part of it. I substituted in, but it's not. So then I get to 1 over 2 root x minus 2's. Now, what is it that I just found? Well, I found the derivative. I found dy dx. I found an equation for the slope of the tangent line at any point on the graph. I'm going to put m of tangent. Okay, so if it asks for the equation, actually not m, it's an equation for the slope of the tangent line. I can find the slope of the tangent line at any point on that graph with that. Okay? All right, let's see what it wanted us to do. It wanted us to find the slope of the tangent line at 2, 0, find the slope and equation of the tangent line at 2, 0 and at 6, 2. So here's 2, 0. That's interesting right there. And at 1, 2, 3, 4, 5, 5, 6, 2, it wanted us the equation. So it wants two answers here. Okay, it wants, well, what is the slope there and what is the equation of the tangent line there and what is the slope out here? What is the slope at that point and what's the equation there? So we'll find them both here. So first of all, let's go at the point 2, 0. First of all, let's find the slope. Well, I'll take my x value and I'll plug it in. 1 over 2 root 2 minus 2, which is 1 over 2 minus 2 is 0. Square root of 0 is 0. 2 times 0 is 0, so I get 1 over 0 is my slope. What does that mean? Well, that means microscopically at this point, that slope right there, it's undefined. It's an undefined slope. And what do we know about undefined slopes? They are straight up and down. So if you were to zoom in like really, really tight there, you would have a straight up and down vertical line. You would have a slope that is undefined. And you would have an equation of tangent. Equation of the tangent. And that equation would be vertical going through 2. That's an excited line. That's an x equals 2 excited line. So here would be the slope of the tangent line at 2, 0. Here would be the equation of the tangent line at 2, 0. Here would be an equation for the slope at any point on the curve. So we got the first part. Okay? The next one was at the point 6, 2. All right, let's come down here. So let's find at the point 6, 2. Let's find the slope at the point 6, 2. So I get the slope is what I would get if I took the x value and I plugged it in. 1 over 2 root 6 minus 2. 6 minus 2 is 4. The square root of 4 is 2. 2 times 2 is 4. I get a fourth. That is an equation for the slope of the tangent line. All right, let's write the equation of the tangent line. Equation. Y minus y1, 2, equals my slope, 1/4. X minus my x value, which is 6. y minus 2 equals 1/4 of x. 1/4 of 6 is 6/4. 6/4 is 3/2. So put minus 3/2. I'll add the 2 over. Y equals 1/4 of x. Adding the 2 over. Well, 2 plus 3/2 is 1/2. And I think it should be y equals 1/4 x plus 1/2. Let's test it. Here's 1/2. That's my y-intercept. Up 1 over 1, 2, 3, 4. 1/2. Up 1 over 4. 1, 1, 2, 3, 4. About right in there. And then, oh, that looks like, I don't know if that's going to fit or not. I think I did my math right. I feel like that's off. X minus 6, 1/4 of x is 3/2. I think I'm okay. I may have made a slight error on that one. It doesn't feel like, you know what? Let's try this clear. Y equals, I'm going to crank this out on my calculator. I'm unsure if this is right. So I'm going to type in the square root of x minus 2. I know what that looks like. And then I'm going to type in this equation down here. Y equals 1/4 of x plus 1/2. 1/4 of x plus 1/2. And I'm going to see if I got it right. You can check these out on your graphing calculator. That looks pretty darn good. Let's see if 1, 2, 3, 4, 5, 6. Okay, so there I am. I'm going to go up. There's a picture of the graph of the tangent and the graph itself. And I'm going to zoom in here. I'm going to see if it comes and if it's tangent at that point. I'm just kind of curious. Does it hit where it's supposed to hit? Man, that's probably pretty close right there. Hey, I think I got it. So sometimes maybe you go through and maybe your graph is a little bit off and you don't quite know. Well, you can test this on your graphing calculator and see if you got it right or not. All right, we got one more. I'll do this one as quickly as possible. The algebra on this one's kind of crazy. Find the derivative, and this one is a rational function where it has a division bar here. Okay, find the slope of the tangent line at an x value of 1. Find the equation of the tangent line when that is it. So here we go. Let's find the limit as h goes to 0 of f of x plus h. So I'm going to go negative 3 over, I'm going to plug x plus h in for that x. Oops, minus 4. X plus h squared minus 4. Okay? And then minus the function, minus f of x, which is minus 3 all over x squared minus 4, all over my h value. And this one gets really kind of difficult from an algebra standpoint because you have fraction over a fraction. But this part right here is the red part. That's the x plus h. I took x plus h, I plugged it in for the x. Everything else stayed the same. Minus my f of x, minus that function all over my h value. And stick with me. This is some great algebra. Okay? What we would have to do here, what we would really have to do is we're going to have to do a lot of simplifying. We're going to have to add these two fractions together by getting common denominators. And the first thing I'm going to do, the limit as h goes to 0, is I'm just going to quickly FOIL this out. So I get negative 3. Oops, I missed that minus sign. See it right there. That minus sign had to come with it. It was minus f of x minus a negative 3. That would have been bad. So I'm gonna go ahead and FOIL that part out right there. Okay. So this part FOILed is x squared plus 2xh plus h squared, and then I still have minus 4. So that is all the same, but I FOILed. Minus a negative 3. I'm just going to put plus 3 all over x squared minus 4. That plus sign, those two minuses can cancel out to make a plus. And now I got to add the two fractions together. Well, this is going to really tax your Algebra 1. I'm going to have to pick a multiplier on the top and on the bottom here in order to do this. And my multiplier that I'm going to pick, I'm even going to change colors for this. Okay, this bottom right here is missing this. So I'm going to have to multiply this one by x squared minus 4 times x squared minus 4 on the top and on the bottom. This is back to your Algebra 2 skills where you have rational expressions and you have the two value and you gotta have the same denominator. This one over here is missing all of that, so I'm going to have to type that in. X squared plus 2xh plus h squared minus 4 is what that's all missing. All over x squared plus 2xh plus h squared minus 4. That's just on the top. All that divided by the h value. Definitely a difficult one from a algebraic standpoint, but nonetheless one we can do. Let's see if we can clean this up. I got the limit as h goes to 0 of, I would use an entire sheet of paper for a problem like this, like spread it out, do it well. Here we go. I'm going to distribute the negative 3 through that parentheses, negative 3x squared plus 12. I'm going to distribute that positive 3 through all those, plus 3x squared plus 6xh plus 3h squared minus 12. So that's on the top. The bottom, I'm just going to leave in that form. X squared minus 4 times x squared plus 2xh plus h squared minus 4. That's the same bottom. All that over h. So that's a little bit better form. I like that. That's not so bad. And let's see what cancels. Well, gone and gone. That was kind of nice. So I got the limit as h goes to 0 of, well, these two. And I'm going to go ahead and I'm going to factor an h out right now. So I'm going to factor an h out of that, and I'm left with 6x plus 3h all over x squared minus 4 times x squared plus 2xh plus h squared minus 4 all over h. But what I'm going to do here, instead of putting it over h, I'll go ahead and put it all over h. I'm going to multiply by 1 over h on the top and on the bottom of this fraction. Now, look at it and see if you see what happens. That cancels that out, and that cancels that out. And I'm left with this over this. Okay, let's write that. Go down a little bit here. I got the limit as h goes to 0 of, well, those canceled out. I'm left with 6x plus 3h all over x squared minus 4 times x squared plus 2xh plus h squared minus 4. And we did all of that so we could use direct substitution and directly plug in my 0 in for all the h's and see what happens. Let's go over. We're going to need some room up above. So I'm going to take the 0 and I'm going to plug it in. Well, 3 times 0, that's gone. So I'm left with 6x up top. Plug in a 0. Well, I plug a 0 in there, that's gone. I plug a 0 in there, that's gone. So these two things are gone. And what I have is I have x squared minus 4 and another x squared minus 4. So I have x squared minus 4 squared, because I got 2 of them. And I got it. I got a kind of a complex equation. This is an equation for the slope of the tangent line. Okay, equation for the slope of the tangent line. So let's go up here, and maybe what I'll do, that was a lot of algebra, maybe what I'll do here is I will, I'm going to put this on my graphing calculator just to see what it looks like. I think that's a good starting point for the rest of the problem. So we're going to go -3 all over, and it's all over x squared minus 4. -3 over x squared minus 4. Looks right. I'm going to graph it. I'm going to zoom back in to where I can see it. Zoom back to my standard screen. And I got this rational looking expression, kind of a funky one. It looks like that, which is really why the equation was so difficult. But what they want us to do is they want to find us the slope of the tangent line and the x value of 1. So when I'm at 1, and you can kind of see where 1 is, if I go over there and I go up to there, if I'm at 1, what's the slope at that point? Well, probably not very much, but positive. So let's go down to here, 6x. Let's go slope at an x value of 1, x equal to 1. I'll plug a 1 in. 6 times 1 all over 1 squared minus 4 squared. I get 6 all over. 1 minus 4 is -3. -3 squared is +9. 6/9 is 2/3. So I got an equation that is 2/3. Okay. Next thing I'm going to do, and it kind of goes something like that. And then there's a branch over here somewhere, and there's a branch up here somewhere. That should be moved over. But that's not the point. The point is, here I am at 1, and I got a slope that's up 2/3. What's the equation at that line? What's the equation at that point? Well, I don't know the y value yet. But since I plugged it in on my graphing calculator, a really easy thing I can do is I can hit the trace button, and I can trace 1. I can hit trace, and I can type in 1. If I hit enter, it'll actually give me an x value, or y value. And look, it says x is 1 and y is 1. In other words, the function value has a value right here. It actually goes through the point 1, 1. So I can use that 1, 1 in my point slope formula and write the equation of this line. So I'm going to go y minus y1, slope, x minus x1. I get y minus 1 equals 2/3 of x minus 2/3. If I add the 1 over here, I get y equals 2/3 of x. Plus in the 1 over there is plus, well, if I add 1 to 2/3, I get 1/3. And that should do it. Here's the slope at the point 1, 1. Here's the derivative down here. This big thing down here was called the derivative. And there's the equation. And one last check. Watch this. I'm actually going to plug in 2/3 x plus 1/3 to end it. 2/3 x plus 1/3 plus 1/3. And I'm hoping, boom, I'm hoping it comes through and it barely clips the point at 1, 1, and I got the equation of the tangent line through that point. Okay, hey, this was kind of a long video, but the way I would treat it is I would treat it as 3 parts, 3 separate problems, and I would use this as a reference. When you hit one of the polynomials without a fraction bar, without a radical, go back through. You could do the problem along with me. You could do your problem as I did my problem, and see how that goes. If you get a radical one, go back and look at that one. If you get a rational one, these rational ones can get kind of big and cumbersome and kind of hard. But those are really the 3 types of problems that you're going to be required to do. So now what you should be able to do is you should be able to go get started on the homework. There will be, I think I'm going to put 2 of each one of these types on a problem. Give you a couple days to do it so that you can ask questions where you need to. But definitely use this video as a reference. All right, good luck.